We've got problem 27, $2,000 compounded semi-annually at 6% for 20 years. All right, so to figure this out, we're going to put it into the equation. A equals, and then our principal is this 2,000 times 1 plus, now the rate is 6%, all right, so that's going to be 0.06, but the problem told it, I didn't write it up here, but the problem told me it's going to be compounded semi-annually, so we're talking about twice a year. So I'm going to divide that by 2. The time is 20 years, but again, because it's going to be semi-annually, I take that 20 and I multiply that by the 2. Alright, so I could simplify this, punch some numbers into a calculator, and what I would end up with is 2,000 times, this would turn out to be 1.03 to the 40th power. And then punch that into the calculator, and what I should end up with is something around $6,524.08. There's problem 27. Let's go ahead and look at problem 28. Similar type of problem. $2,000 compounded monthly, and all the numbers are the same. Like the only difference is 27, it's compounded semi-annually, and 28, they give us the same numbers, but then tell us that it's going to be compounded monthly. So the only difference is this number here. This is still going to be 2,000. I'm still going to have 1 plus 0.06, but now compounded monthly, meaning 12 times a year, right? So this will be divided by 12, and this will be 20 times 12 up there. So you simplify that a little bit, and what you would end up with is 2,000 times 1.005. But then we're taking that number to the 240th power. And if you do that calculation, what you end up with is about $6,620.41. So it's interesting to kind of compare these two numbers for a second here, right? Because this just shows you what the difference would be. If it was compounded semi-annually, you end up with 6,524. If it's compounded monthly, you're getting about $100 more. It's a little less than $100 more, but pretty significant amount. Okay, I want to do one other problem here. Let's see, I wanted to try, I think, problem 31. So let me turn there in my book over here. 31, we're told a patient takes 500 milligrams of medication, and the amount of medication in the patient's body decreases by 10% an hour. So he's got 500 milligrams, and it's decreasing, so I'll just put a little down, by 10% every hour. So here's where we're going to go back to the exponential function. The initial amount is 500, okay, so I'm going to say, I'll just put, I guess, what, f of t. F of t equals 500. Now, it's decreasing 10% per hour, right? Okay, and actually I should say, I should call this f of x because the problem tells me write an exponential function using f of x. So let me change that real quick. That's f of x. Sorry. Okay. Yeah, part A was write an exponential function f of x modeling the amount of medication in the patient's body. Okay, so this number is still the same. 500. Now, if it's going down by 10%, what I want to do is 1 minus 0.1 because it's decreasing, right? And let's see, they tell us, well, I guess it's just x. Yeah, I mean, this is part A. This is a multiple part problem. So that's going to be the function right there. Now for part B, for 31, they ask how much medication to the nearest milligram is in the patient's body after 4 hours. So now we're actually going to, for part B, plug in 4 for x. So this will just be 500 times, okay, 1 minus 0.1, that's 0.9. And then the hours would be 4. So we're taking it to the 4th power. And you punch that into a calculator, you're going to get about 328 milligrams. Now part C for 31 is graph the function showing the amount of medication in the patient's body for the first 8 hours. I am not going to actually draw the graph, but I could show you a table real quick because I think you all know how to plot points. But all you'd have to do is say, okay, well, here's my x, here's my, we'll call it y, and you would just, start at 1, and then you'd plug stuff into this equation right here, right? And if you did that, 1 would give you about 450. 2, and again, you're just plugging it into this, 500 times 0.9 to the x, but this would be 2 instead of 4. I hope this is not confusing, right? So this would be about 405. 3 would be about 365. 4 we already did. We did 4, so 4 would be about 328. Maybe do a few more, and then you would just take those and plot them on the graph and draw the graph. So hopefully that wasn't too confusing, right? You're just taking these numbers and you're plugging them into f of x equals 500 times, I'll go ahead and simplify this part right up here. This would be 0.9x. So I'm just taking the 1, plugging that in, taking the 2, plugging it in, and then finding what it equals.